Assalamu alaikum, this is Mr. January and now I am discuss about my ML Talks second round. Mainly this round contain 4 questions related to how different data structure and algorithm can be used in ML and distributed system. Let's start. So number one question is about GHS algorithm for minimum spanning tree. So GHS algorithm is a distributed algorithm used to construct a minimal spanning tree in a completed in a connected weighted and undirected graph. It is useful in a system when each node is independent and communication happens through their messages passing between connected graph. Now let's talk about the working process of GHS. Initially, every node is a fragment, and all are in level 0 with an ID. Each fragment find its minimum weighted edge that connect it to a different fragment. Then fragment connect using those edges and merge into a large fragment. This process continues until only one fragment remains, and we find the MST. So here is an example of this. We can see the graph of this. Here is 5 nodes, and if I discuss about this, the age. If I talk about the ages with weight, then A to B is weight is 5, A to C weight is 4, B to C weight is 2, and B to D is 6. That's all. And these ages are in level 0, and all the nodes are different fragments. So if I talk about the first step, or the first round, first we have to find the minimal outgoing edges for every node, which are these. First merge E and F, and we can find a new fragment which is DE, which is given is there. This tree is made. Then if we connect the B and C, then we see this tree we will find. All this equation or all these tree merge or connected simultaneously. Then later we want to connect the D and E. E is already connected to F, so that this D is connected to E and also the F. So there happen a new fragment which is D, E, and F. Kind of this. A and C try to connect. So there is C is connected with B. So A, B and C is create a new fragment. And there was a leader which I can see B or C. And here is the final fragment. Like this. If we step down like round 2, then the merge one, merging this 2 fragment which is D, E, F and A, B, C. We can find the A, B, C and A, B, C, D, E, F. Because D and E with the B and D weight, which weight is 6, there is B, this is the connected through, so we can find there is the MST, which is the A, B, C, D and E, and E and F. So this can be a minimal spanning tree. Now move on. MST in machine learning. In machine learning, MST is used in several real world applications like feature selection, data clustering, image segmentation, sensor network optimization, and that's all. Let's talk about the question 2. The best data structure to enable order of log and ranges. Some queries and updates would be segment tree or a Fenwick tree. As the requirement said, the exact and the approximate aggregation, a segment tree is more efficient. or effective. So let's discuss about the segment tree. A segment tree is a binary tree for maintaining information about ranges. It's mainly uses for efficiently updating and query ranges. Each node of the tree represents an interval. These nodes contain not only the simple sum, they also contain more complex object. Now let's talk about the how the parallels updates for distributed features stored. The parallelization strategy involved a combination of sharding, then functional programming and conflict resolution. Sharding is mainly partition data either by their user ID or time range. Then the functional update use accession operation so that multiple update can be merged. And the conflict resolution use optimize concurrency or CRDTS for safe update across the distribution worker. These designs allow to handle large and interaction some efficiency in real time. Now let's jump on the question 3. In ML models, we need to store read type frequently and frequently used model or data while making prediction, which is called ML model cache. A split tree is a self-adjusting binary search tree that brings the most recently accessed model to the top, which improves the average access. This is the working process. When a model is accessed, it is moved to the root through the rotation. Recently accessed model become faster to access next time. Over time, the tree adapts to access the pattern, which produce access time order of log n. If I tell the comparison between the split tree and LRU caches, then split tree learns from the users or the users. This needs less memory and it is very adaptive to learn. Where the LRU's cache access time is order of log 1 but need higher memory and no adaptive learning. There is the split tree or the splitting harms latency. When all the models are used equally, then the latency happens. When models are rarely reused, then it may occur. When the deep rotation occur in a real-time system. Mainly there are some option where LRU is better, and there is some other option where where the split tree is better. Now the last question is about the disjoint set union, which is also known as union find. On a social network like Facebook or Instagram, users are considered as a node and being friends are considered as a edge between the nodes. Where the adding or removing new connection, we have to find out the disconnected community is the same. To find or merge this in a efficient way, we can use DSU or disjoint set union. DSU is mainly two sets when they don't have any common element. I mainly do operations like this union of two disjoint set to a single set, finding a representative of a disjoint set by using find operation, verify if two objects belong to the same set or not. Now if I talk about the optimization, there are two techniques that make DSU fast, almost order of 1 per operation. One is unique by rank. This sets has a rank or a level. When merging two sets, put the smaller tree underneath the larger tree. It keeps the tree shallow. Then the path compression. When we do find operation, we have every node on the path simply point to the root. This reduce the tree depth for the future looks up. These two together make each other optimization nearly order of one time, which is crucial for large scale machine learning graph or system or clustering or connected component analysis. Now if I talk about the example, suppose we have 5 users A, B, C, D and E. At the beginning, each user has its own path or own parent, which are the separate tree A, B, C, D and E. So first step, we have to find we have to merge the single component or the tree. If I add A and B, then union of A, B, then find the root of A, which is A, then find the root of B and which is B. So B and A and B is connected component. All the so there is all the connected component or all the component are A, B, then C a single component, D is another single component and E is another single component. So if I then go to the step 2, then if I add the age of B and C, then union B and C, find the root of B, which is A, and the find of root of C, which is C. Now I have to merge C under A. Now the tree become like this. Now ABC is one connected component and the other component is D and E. So I have to connect it D and E. Here is the connected component of DE. So then we find the ABC and DE, the two different component. Step 4 is query making. RA is connected to C. Then find A, which is A. Then find C operation, which is A. Yes, they are. Then we can show the result, which is yes, they are at the same component, because this is A and this is C, and A and D is connected. We see A and D and are not connected. D and E are connected, and A, B, C are connected. So the result is no, they are in different component. So step 5 is we have to add the CD and CD. So connected union is C and D. We can see that C, D is connected through a line of A. So merging these two attach D under A, or vice versa, it can be label different. Now the final tree is this A, B, C, D, E. If we have to find E, then we can find E, D, A, or A, D, E. After the path compression, E point directly to A. In future, we can find it in order of 1. That's all about my discussion. Thank you.